Hi everyone, we are back and we are about to go through our Pset 4 solution videos. So let's go ahead and get R up here moving. And we have our handy dandy tables and let's get going. So let's start to define some features here. And then let's come at. All right, so let's go to tidyverse. Let's do library. Our statics, stats. There you go. Okay, so let's just read in bang, bang, bang. Let's delete all of this good stuff, and let's instead go to so 3 different materials. So I have basically nx equal or nx goes to 14. We have ny goes to 87, and nz goes to 8. Okay. 87, 8. X bar goes to 123 joules. Y bar goes to 126 joules, and Z bar goes to 120 joules. Excellent. And then SX is 5, SY goes to 0.9, and SY SC goes to 0.08. Good. And then now we need to look at calculating confidence intervals. So we're going to have to pick out effectively T values, and we can set up those 90 and 95% confidence intervals. And we can go ahead to do that. Let's go ahead and pull up our so let's go ahead and find these table values. So we'll go over here. We'll try to clean this up a little bit. And let's start to set some values that we're going to need. So we're looking at 90, 95, and 99% confidence intervals. So if we know that our alpha is equal to 0.1, that's our 90% confidence interval. We need to divide by 2. So we're going to be looking at this column. We're going to be looking at 0.25, and actually, so here, we're going to be looking at this column. 95 alpha would be equal to 0.05, so we're going to look at this column, and then alpha equals 0.01, but then divide that by 2, then it's 0.005, so we're going to be looking at this column as well. So we said, what were our values for, so we're looking at x is 13. We're going to be looking at values of y is going to be infinity, and then z will be equal to 7. So we can go ahead and draw a line under those values. So actually, let's delete right here. So bang, 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 and then bang, bang, bang. So we can start to type those values because we're going to need that. So let's go ahead and get to typing. So let's go ahead and do, we'll say T, here we go. We'll do T of 05, new of, and then we'll just call that one T05 new X. Or T05X, because that's going to be, actually, ooh, that's T05 Z is going to be 1.895. We're in T025Z goes to 2.365, and T005Z goes to 3.499. So let's bang, bang, bang. And let's do T05 X. Correct? Ah, shoot. No, I did that correctly. T05X is going to be equal to 1.771. T05Z, or T025X goes to, you can see this is pretty laborious, but 2.650. T of 02 or 005X goes to 3.012. And T05Y, yeah, T05Y goes to 1.645. We should put this, make it consistent. T025Y goes to 1.96, and T005Y goes to 2.576. There we go. Okay, so what was this question actually asking us to do? So the question is actually asking us for, does that value fall within the 95% confidence interval? So we can actually go about and do that now. So we're just going to take, for example, let's do all of Z, or actually, yeah, let's do X first. So I'm going to do X bar plus SX divided by square root, actually, SX times, or actually, let's do it in order, times T05X times SX divided by square root of NX. So that'll be our first value, and then we'll do the next value too. So bang, 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 bang. And we'll just change, this needs to be 025, this should be a minus, this should be a minus, this should also be a minus. And T025, T025, T0000. And so now we can see all those values. So yes for 90, yes for 95, yes for 96. Now we can do the same thing for Y. So Y bar, then we can do Y bar plus T05Y times SY divided by square root of NY. And we can get that value here. Toot, 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 toot. So it's minus, this is minus, and this is minus. And then 025, oh, actually that should be 05. 025, 025, 00, and chug along the way. Nope. Actually, nope. 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 So that's your answer for Y. And then finally, for Z, we can get moving here. Z. And it's just typing it in. Next time I probably would have defined a function. T05C. This is Y. For sure next time I'm going to define a function to do this. So I don't have to do this each time, but either way, it's alright. But a function would be a lot nicer. But sometimes you can just brute force it. What does it say? TO25s. Do we not have a TO25Z? that variable needs to be redefined. So now we can go, nope, 124 is not in there, not in there, not in there. All right, excellent. So attached are 3 data files. Calculate the confidence interval. So this is what I like to do. I really like this one. So let's go ahead. Let's look at our downloads. Let's bring these data sets into, actually, maybe are they already in the documents? No. So let's bring these into our documents. Let's bring them into my docs. Let's open this up. We're calculating those 90, 95% confidence intervals. Let's set this as our working directory. So now I can do, if we look at these, here we go. So I'm going to do P1 goes to read.csv, PS4-1 1.csv. Enter, that worked. So now I'll do P2, P3. And I'm going to be smart now with the code this time. So let's do 2. Let's put a 2 here. Let's put a 3 here. Oops. So 1, 2, 3. All right, so now we can do t-test. And then let's do P1. Actually, well, let's go ahead and I think we're going to have to do P1, bracket 1. Actually, let's look at the value. 2, P3. Actually, let's see what P1 looks like. So we have just these rows. The values are actually in that second column. So we just want P1, actually bracket 2, because we want those values. Okay, so we could do t-test P1, bracket 2. And if you remember in your t-test, it'll actually give us that confidence interval. But we'll have to specify it. So let's just say we want the t-test, we want the alternative to cited, to dot cited, and then we also want my confidence level to be equal to, so let's do 90% confidence interval first. You can see the 90% confidence interval here, and now we can just change that to 90, 95, 99, I believe. That's what we're looking for. 90, 95, 99. And this is nice if we have the raw data, because we can just go boom, and then boom. So you can see essentially all those different, there's my confidence interval here, there's my confidence interval there, and you see it's basically growing each time, which makes sense. And we could do the same thing for P2 and P3. P2, P3, P2, and Tooch. Confidence interval 90, 95, 99. And then for P3, let's get that over here. 3, 3, 3. And again, it doesn't matter if you have large sample size or small sample sizes, it'll give it to you. 90, 95, 99. There we go. All right. Check. Prove the central limit theorem is true for a population with a uniform log and binomial distribution. Provide your R script that illustrates with the relevant histograms. So we did this in a video. So in our lecture video, you have that solution already. So we'll see you in the next problem set. Thanks. Bye.